Welcome back to DDL's PackReview series. Today we are going to talk about compression testing. My name is Pete Johnson and with me is Scott Levy. Scott, what issues do you see with compression testing?
A lot. It's probably one of the biggest questions I get, and it has to do with ASTM D4169, Schedule C, the vehicle stacking. A lot of our clients for medical device don't meet the calculated specified load.
And what does that mean? If you don't meet the calculated load, do your packages fail?
Depends upon who's reviewing. If you get people in quality and regulatory and they're looking for everything that says pass, technically you could construe that as a failure. From my perspective, is that a failure? No. Transportation simulation is a conditioning test, meaning that you're executing the testing, but you need to understand afterwards whether you pass or fail, based upon product testing, sterile barrier testing, whatever you're trying to look for after that specific test. For electronics, might be cosmetics, might be whether the product functions properly. Again, medical device, you want to prove out that the sterling maintenance hasn't been compromised. You might want to look at the label, but none of that has any bearing on the actual transit procedure itself. That's why I classify that as a conditioning test.
Regarding the stack height in the compression testing, I know they have 108 inches listed out in the standard for vehicle stacking. There's a little notes on caveat on 54 inches.
Yeah.
Could you go into that a little bit?
Absolutely. So the default is 108 inch stack height. And where's the 108 come from? That's from a tractor trailer. Okay? The measurement of the back of a tractor trailer from the floor to the ceiling is 108 inches. Why do we use that? Because there's an assumption made that we don't know how this package is going to be shipped. FedEx, UPS comes and picks up the boxes, right? They will take it with a step truck to the airport or to the distribution center, where it's going to get packed up into either another step truck to go to the airport, or it's going to get stacked in the back of a semi for transit. So you never know which way it's going to go. When you talk with FedEx and UPS, they just need to get there in a specified amount of time that you're asking them to get. So from a package testing side, you don't know how it's going to go. That's why the default is 108. Now, when customers fail the compression testing, per se failed the compression testing, then they'll look at the standard and look at another number that says 54 inches. What that 54 inches is truly meant for is LTL shipment. What is ultimately LTL shipment? It is less than trailer load, meaning nothing is going to get stacked on top of those boxes. Another aspect where you could use 54 inches, if I had a company van per se, and I was sending it across from Minneapolis to Madison, Wisconsin, Milwaukee, where we're not using a big 108 inch high semi. At that point, sure, you could go ahead and bring that down to 54 inches to mitigate those compressive loads because of your known specific distribution environment.
What are some ways that people could go to, overcome failures they observed in the compression vehicle stacking?
On average, I think it's about 70-30. Okay, 70% of people pass the compression test, 30 people with the per se don't pass that compression test. Two ways to look at this, all right? Again, it's a conditioning test. What you do afterwards tells you whether you pass or fail. You're looking at the specific amount of weight that this box is actually achieving. For example, let's say the compressive load was supposed to be 1,200 pounds and your box meant 890 pounds. Well, that's a heck of a lot of compressive force for that specific box. So you know that if your box fails out in industry, something heavier than that 890 pounds was put on top of it. We also know that for sterile medical packaging, that if the boxes are damaged in any way, they get rejected and sent back. No one's going to play with a box that has sterile devices in it and take any chance on it. A couple ways to mitigate it if you're really trying to do it is beef up that box. Make sure that the flutes are running the right way for our compression test. We can talk about that later, but that's probably a key aspect because you're not breaking down the structural integrity. Now, if you beef up that box, you're also adding what to the bottom line for each package configuration?
Your costs.
Your overall costs. So there's a couple things that I would look at. I would look at, if you really want to beef up that box to make sure that you get through this conditioning step, then what I would do is look at the overall cost and what your risk is. All right? Most medical device manufacturers have shipped products all over the world. Okay, what percent defect is from crushing? What percent defect are they having issues with? That simply those boxes are compressing to the point that the sterile barrier is breached. Once that happens, yes, then I'd take a good close look. But if this is an occurrence of 5-10 boxes out of 10,000, is that a risk that you're willing to take when you know these boxes are going to be sent back? So you've got to balance that. What risk are you willing to take based on you know that your box is going to handle 890 pounds versus adding $5-6 more to a box construction to get through a conditioning step?
You mentioned having your flutes in the correct orientation for compression testing.
Yep.
I know that that's based on some of the descriptions on how to test samples for 4169. Could you speak to that a little bit?
Sure. Obviously, you've got a wide package, a really wide package. The flutes aren't going to run the correct way for compression strength. The 4169 standard talks about testing in the most stable orientation, right? Well, the most stable orientation would be that wide platform, because either they're probably they could lay this down and things could get stacked on top of it. Would you be looking at problems in shipment? Potentially, with compression. Because if you put that box into compression testing and the flutes are not running the correct way, you have absolutely no strength to that box. So when you're designing your package configuration, you need to take that into consideration, because that's key. It's imperative. For medical device, we're not dealing with long, 3-foot wide boxes by 12 inches thick. But if those flutes are not running the right way, you have absolutely no compressibility, or no compressive strength, I should say, with that box. So designing, if you're way up front and you're designing a box, that's what you're after. For testing, any of the testing, the most stable orientation, could you run into issues? Well, sure. But you know that the common carriers are going to put this in their semis, step trucks, except in the most stable orientation, so this thing doesn't keep falling down.
How would you go about justifying a sample that didn't meet the compressive load?
Ultimately, there's a couple ways I'd go about doing this. I would look at how much weight that the box did meet, okay? Again, 800 pounds versus 1,200 pounds. Is that a lot of weight? Yes. So I would look at that. I would look at the transit procedure as a conditioning test. That's not really a pass-fail test. It's a conditioning test. And what happened afterwards? If it was sterile barrier testing, did we pass all of our testing? If that answer is yes, then from my opinion, that configuration is a solid configuration. If you want to go one step further, now we're going to talk about your overall risk. You never want to default, or you never want to lose sight of your real-time data. Okay, all the stuff that you have out and about currently, are you having these types of issues? If your percent defect is low enough, then again, I would look at this as a conditioning test, that the ultimate primary goal of this test was to ensure that the sterile barrier was not compromised by shock and vibration.
Thanks again for joining us for PackReview today. If you have any questions, visit our website at www.testedandproven.com.